Diagnostics should always begin with a thorough inspection of the basic system components. Diagnostics for the Subaru SVX Auto HVAC system is no exception. Before analyzing the automatic control portions of the system, always perform the basic preliminary checks. After these checks, test the compressor on and off operation and the sight glass. Install pressure gauges to the high and low sides of the AC system and check for proper refrigeration system pressures. The SVX Auto HVAC system has two options for diagnosis: a self-diagnostics program built into the system and the Subaru Select Monitor. Self-diagnostics and the Select Monitor should be used together for thorough and accurate diagnosis. It is important to understand that diagnostics can only lead to the general area at fault. Proper troubleshooting procedures are required to determine the exact failure. There are three modes within the self-diagnostics program: the bulb and actuator check mode, the fault code display mode, and the output signal recognition mode. To start self-diagnostics, the ignition switch should be off. Depress and hold the off and auto switches, then turn the ignition switch to the on position. The system automatically enters the bulb and actuator check mode. Each LED, except off and outside temperature, will illuminate as amber, then change to green. The temperature indicator displays full lighted segments, and each actuator moves through approximately one full cycle of travel. Following the bulb and actuator check mode, the system automatically enters the fault code display mode. There are 17 possible fault codes. Any current failure will be displayed as a two-digit code in numerical order. If no codes are present, 00 will be displayed. The service manual describes each of the codes. Remember, diagnostic fault codes can only lead the technician to the general area of the problem. For example, fault code 12 indicates an open ambient sensor circuit. The fault could be within the sensor, at the sensor connector, anywhere along the wire harness, at the ACU connector, or within the ACU. Special attention must be given to code 13, which indicates an open sun sensor circuit. If the vehicle is being checked in a shaded area or under fluorescent lighting, the code may be invalid. If, after directing an incandescent light source at the sensor, the code still appears, it is valid. Most fault codes only indicate a complete failure, either an open or short circuit. If a system failure occurs and a fault code is not available, refer to the service manual for inspection procedures based on fault symptoms. Failures which have occurred at least 16 times will be stored in the ACU memory. These codes must be cleared following the repair. To clear the memory, turn the ignition switch off while in the fault code display mode. Hold the off and defrost switches down and turn the ignition switch on. Following the fault code display mode, the output signal recognition mode is accessed by depressing the auto switch one time. The defrost LED and mode 41 are displayed. The ACU program has 6 predetermined output signals which are sent to the HVAC system controls during this mode. The control HVAC components should respond as shown in the service manual. To advance through the 5 output signal recognition modes, depress the defrost switch. To return to the fault code display mode, press the auto switch one time. The Select Monitor works in conjunction with the self-diagnostic system and provides detailed information about the system inputs, outputs, and component operation. With the correct cartridge inserted and the cable connected, any of 19 different function modes can be accessed. Functions such as actuator position, actuator command, compressor displacement output signal, or sensor values. Refer to the appropriate service manual for a complete listing of the function modes. Two special functions of the Select Monitor are the control panel switch test and the fault code display. The service manual contains a complete listing of the correct LED and liquid crystal displays for each switch position and a detailed explanation of the fault codes. Intermittent code stored in the ECU memory will not be displayed on the select monitor if the fault is not present. To determine if there is an intermittent failure stored in the ECU memory, use the self-diagnostics mode. Once the general area of failure has been determined, further troubleshooting will locate the specific component problem. Caution must be taken when testing the electronic components. Many of these devices can be damaged by voltage spikes and should never be disconnected with power to the component. The system operates on low voltages, and loose or misaligned electrical connections can result in excessive resistance and false readings. Always release the retaining tab and gently pull apart by the connector body. Never pull a connection apart by the wire harness. When making connections, always be sure that terminals are correctly aligned, seated completely, and that the retaining tab is secured. Detailed information regarding connector servicing procedures is found in the service manual. The service manual also contains troubleshooting flowcharts for each fault code and for failures which do not have a fault code. Some troubleshooting procedures require testing with electrical connections made, while other tests will require readings with the components disconnected. Service manual flowcharts approach each failure in a similar manner. Each chart begins with the examination of the input and output device. Following this test, the chart leads to the ECU test procedures. After these areas have been proven to operate properly, the chart leads to the harness test. Each step should be followed carefully to avoid false readings. To demonstrate some typical troubleshooting procedures, 4 examples will be presented. Ambient sensor failure, 2 types of actuator failures, and a no cooling complaint with the compressor engaged. To troubleshoot the ambient sensor circuit, disconnect the sensor and measure the resistance across the 2 sensor pins. At 77 degrees Fahrenheit, the reading should be approximately 3 kiloohms. Remember, the readings will vary according to temperature. Always consult the service manual for the specific sensor specifications. If the reading is not within specifications, the sensor is faulty and should be replaced. If the reading is within specifications, proceed to the reference voltage check. Measure reference voltage at the ambient sensor connector. The reading should be approximately 5 volts. If the reading is correct, the ECU is at fault. Replace and recheck the ECU. If the reading is incorrect, proceed to the reference voltage signal check at the ECU. Reference voltage should be approximately 5 volts. If not, replace the ECU and retest. If the reading is correct, the harness is at fault and should be repaired or replaced. Troubleshooting procedures for the mix and mode actuator circuits are very similar. The charts are divided into 2 areas: potentio balance resistor, or PBR circuits, and motor drive circuits. Fault codes will lead to the correct starting point of the chart. Because of the similarities between the 2 actuators, only the mixed door chart will be discussed. Remove the ECU and access the self-diagnostics output signal recognition mode. Check the voltage between the PBR signal return pin and the sensor ground pin. Depending on the output signal recognition mode, the reading should be approximately 5 volts, approximately 2.5 volts, or approximately 0 volts. If the reading is correct, proceed to the motor drive circuit portion of the chart. If the reading is incorrect, proceed with the PBR circuit check. Disconnect the actuator and measure the voltage between the reference voltage pin and the sensor ground pin. The reading should be approximately 5 volts. If the reading is not correct, the ECU is faulty and should be replaced and the system retested. If the reading is correct, check for continuity between the actuator connector and the ECU connector terminals as indicated in the service manual. If the readings are not correct, the harness is at fault and should be repaired or replaced. Correct readings indicate the actuator is faulty. The motor drive circuit check should be used if the results of the PBR check were correct, or if the fault code leads to this area. Use the output signal recognition mode to provide a motor output signal. Measure the voltage output of the ECU as indicated in the service manual. Reverse the direction of the motor by selecting the appropriate output signal and verify reversed output voltage. Incorrect readings indicate the ECU is at fault. If the readings are correct, proceed to the motor harness check. Check for continuity between the actuator connector and the ECU connector terminals as indicated in the service manual. If the readings are not correct, the harness is at fault. If the readings are correct, the actuator is at fault. The intake actuator chart is not divided because this actuator uses position sensing contacts. To check the intake actuator circuit, remove the glove box. Measure the source voltage at the actuator connector. The reading should be at least 12 volts. If not, there is a fault in the voltage source wiring. If the reading was correct, check the motor control circuits with the ECU in Self-Diagnostics Output Signal Recognition mode. If these readings are incorrect, the ECU is at fault. If these readings are correct as indicated in the service manual, continue on to the harness check. Check the continuity of the wiring for open or grounded circuits at the corresponding pins. If the readings are not correct, the harness is at fault and should be repaired or replaced. If the readings are correct, the actuator is at fault. Troubleshooting flowcharts should also be used for failures which do not have a specific code. One such case is poor cooling with the compressor clutch engaged. If the preliminary checks did not reveal a fault, refer to the appropriate flowchart. Begin by checking the control current at the compressor solenoid. If the compressor solenoid current is correct, the proper air mix door operation or the proper compressor displacement should be verified. Compressor displacement is tested using the refrigerant gauges. Use the output signal recognition mode to drive the compressor from maximum to minimum displacement and note pressure changes. If the compressor solenoid current was incorrect, check the solenoid resistance. If the solenoid resistance is not correct, the solenoid is at fault. If the resistance is correct, the ECU or the harness is at fault. Remember, every suspected failure must be approached in a logical manner. Work closely with the service manual. Good diagnostics, followed by thorough troubleshooting, will result in accurate and efficient repairs.